Hello everyone, welcome back to another lesson on sequences and series. Today we are going to be looking at sigma notation. Now before I actually define what sigma notation is, I'm going to ask you a question. Have you ever thought about the possibility of an easier way to write down a long sum? Especially with series, it can be quite tedious to write down all the different pieces of the sum with the different letters involved, but luckily I've got good news for you. Sigma is an easier way for us to indicate that there are terms that have been summed together. Let's look at the board together. So everyone, today we are going to be looking at different series. We're going to be looking at arithmetic series as well as geometric series, and we are going to be defining what sigma is and how sigma can help us in series. So the key terms that I just want to revise before we get into it, just a reminder that an arithmetic series is formed when the terms of an arithmetic sequence are added together. So please just remember that there is a difference between an arithmetic series and an arithmetic sequence. If you are given the list of numbers 4, 7, 10, 13, 16, and 19, this is an arithmetic sequence. The reason why it is an arithmetic sequence is because it's a list of numbers, and this list is indicated by the semicolons. But underneath that line, you can see that I've got 4 plus 7 plus 10 plus 13 plus 16. This is an arithmetic series. It is a series because it has plus signs, so it's involving the addition of specific terms. Great, let's look at geometric series. So geometric series are formed when the terms of a geometric sequence are added together. So similar to the arithmetic series, I've now got a list. So I've got 3, negative 9, 27, negative 81, 243, negative 729. This is a geometric sequence. Why is it a sequence? I've got semicolons. Please remember that sometimes you have commas. It's indicating that it is a list of terms. A list of terms is a sequence. But the main difference with a sequence and a series is now we've actually got terms that have been added together. So it's the exact same terms, except I have now added the values together. So when I add the values of a geometric sequence together, it is a geometric series. Great, I hope that everyone's with me so far. So just a reminder, a sequence is a list of terms in a pattern, and a series is when I add the values of the terms of a pattern together. Great, let's go to the board and see what's next. So this is the main topic for today, our focus. We are going to be talking about sigma notation. What sigma is, it is this symbol. It's a weird looking E, but what it means, it is an instruction to determine the sum of a sequence. The use of sigma in series gives us the opportunity to add any consecutive terms in a sequence, and not only. So please remember, it's not going to only be the first n terms of a sequence. So hopefully everyone's with me so far. Sigma is an instruction to add terms in a sequence together. So it relates to series because I'm adding terms together. But the cool thing with sigma is that it doesn't have to just be the first n terms. I can start my addition from possibly term 5 going up to the end, or term 7 to term 11. Sigma allows us to add a portion of the sequence together. Let's go back to the board. So guys, what I have given you over here is an instruction involving sigma. So you have been instructed to add the values of tk from k is equal to 5 to k is equal to 11. I know this is a bit new, but let's look at the pattern. We can see that the first part of the sum is t5, which matches the k5. So that's the starting term number. The number at the top is the end term number. So we can see that we have added from term 5 to term 11. And if I want to see how many terms have been added together, I can see that there are 1, 2, 3, 4, 5, 6, 7 terms involved in this sum. Great. Let's look at the next one. We now have a sigma sum, again with tk, but I'm starting from term 8. And we can see that k is equal to 8 at the bottom. This is indicating the first term that is involved in the sum. And the end term that is involved in this series is tn. So the last term of the sequence is being added. But if I ask you how many terms have actually been involved in this sum, we can see that we've gone from term 8 the whole way up to term n. So I'm hoping that everyone will agree that term 1 to term 7 were not included in the sum because I start at term 8. So it is the sum of n minus 7 terms. Why minus 7? 7 terms of this sum were not included. Great, let's go to the next slide. So after our little investigation, we can actually conclude how we can add the number of terms involved in a sigma sum. So in general, in order to work out the number of terms being added in a series, using this little sigma illustration, the number of terms involved in a series is n minus k plus 1. But a much easier way for us to write that is it's the top number minus the bottom number plus 1. So if I want to know how many terms I'm actually adding together in my series, I take the top number, the number on top of the sigma sign, I subtract the bottom number, and I plus 1. Great, everyone. So I'm hoping that everyone is with me so far. What I've covered is an introduction to sigma. Sigma is an instruction to sum a certain number of terms within a sequence together. We know how to determine how many terms are involved in that sum by taking the top number minus the bottom number plus 1. After the break, we will be getting into some more examples of how to do this. See you soon. Welcome back, everyone. Before the break, I had just introduced what sigma notation is. Sigma notation is an instruction to sum a certain number of terms together of a sequence. Now, in this part of the lesson, we are going to be looking at some examples of how we can do this. Let's go to the board. So, guys, just a little bit of a summary of what we have covered is when we are using sigma to calculate the value of a series, we need to actually write down the first 3 terms of the sequence. Why do we need to write down the first 3 terms of the sequence? This is going to allow me to establish the value of A as well as D if it is an arithmetic series, and then R if it is a geometric series. So guys, please know that we still need to know what A and D are for arithmetic, or A and R for geometric. because we ultimately are still going to be substituting into our series formula. So the sigma instruction is going to help me find the first three terms, and I know that if I have the first three terms of a sequence, I can find A, and I can find D if it's arithmetic, and I can find R if it is geometric. Let's go back to the board. So let's look at this first example. I've been asked to calculate the sum of 2n minus 1 from 12 to 52. So something that I want everyone to note is that this 2n minus 1 is my Tn. So this is my nth term for the sequence. But before I can actually do this sum, I need to know what term 1, term 2, and term 3 are, as that's going to help me substitute into the series formula. But I have to remember that the first term involved in this sum is the 12th term. So for this case, I'm not actually going to be using term 1, term 2, and term 3, because term 12, term 13, and term 14 are the first three terms involved in this sum. So please remember, this is going to be my A. So term 12 is going to be my A value. So the first number that I'm going to substitute in for n will be 12. So we are going to substitute in n is 12, n is 13, and n is 14. This is going to give me the first three numbers involved in the sum. So all that I've got on the board now is substituting in 12 for n, 13 for n, and 14 for n. Let's see what the first three terms would be. So I've got 2 times 12 minus 1, which gives me 23. Then I've got 2 times 13 minus 1, which gives me 25. Then I've got 2 times 14 minus 1, which gives me 27. So the first three terms involved in the sum are 23, 25, and 27. So because I now have the first three terms of this particular sum, I can actually establish my A and my D. And that's going to be helpful because I want to substitute into my arithmetic series formula. I can see that A is 23. If I look between 23 and 25, I can see that there is a common difference of positive 2, because 23 has increased by 2 to get to 25. Then from 25 to 27, I can see that there's been an increase of positive 2. As my common difference is the same, that means that it is a confirmation that it is an arithmetic series. Okay guys, so we are almost there. We're almost at the point where we can sub into our arithmetic series formula. We have A and we have D. But we still need to know how many terms are actually involved in this sum or in this particular series. So we're going to use the trick that I told you before the break, where we take the top number, the number on top of the sigma, minus the bottom number under the sigma sign, plus 1. This is going to tell me how many terms are actually involved in this series. So let's do that together. So we're going to take the top number, which is 52. We're going to minus the bottom number, which is 12. Then we're going to add 1. So 52 minus 12 is 40, plus 1 is 41. So we know that there are 41 terms involved in this sum. Great, guys. So now we have our A, we have our N, and we have our D. At this point, I can now substitute everything into my arithmetic series formula, and then I can actually determine the value of the series at this point. Great, guys. So let's substitute in. So I'm going to take the sum of the first 41 terms, which means I'm going to have 41 over 2. I'm substituting in n, which is written over here. I'm going to have 2 times my a, which is 23. This is going to be added to 41 minus 1, again substituting in n. Then I'm going to substitute in d, which is positive 2. Then if I make the next line that's slightly more simple before plugging into my calculator, I'm going to have 41 over 2, 46 plus, sorry, that's going to be 40 times 2. So let's plug this all into the calculator. So we're going to have 41 over 2 times 46 plus 40 times 2. So this series has a value of 2,583. Wonderful. I hope everyone's with me so far. We have done our first example of evaluating a series using sigma. Let us have a look at our next example together. So we now need to write down the following series using sigma notation. So essentially, instead of me telling you you have to use sigma, we are going to represent this specific sum in sigma notation. So the series goes 4 plus 11 plus 18 plus 25 plus going the whole way up to 151. So I now need to represent it in sigma notation. I'm going to have my nth term to the right of the sigma. I need to know what number I start substituting in, and I need to know the number that I go up to. But we're going to work that out all together. Cool. So I'm hoping that everyone will agree with me that the first term has a value of 4. So that means that a will be equal to 4. If I'm looking for my common difference, I can see that positive 7 has been added each time. So from 4 to 11, we know that you add 7. We know that from 11 to 18, I have to add 7 again. And in order to get from 18 to 25, I'm going to add a value of 7 again. So my common difference is in fact 7. Wonderful, guys. So I hope that everyone can see that because I now have my A as well as my D, I can actually find my Tn or my nth term. Why do I want my nth term? My nth term always goes to the right of my sigma sign. So figuring out what my nth term is allows me to substitute that into the sigma notation. Let's find the nth term together. So because I'm going to be finding out what Tn is, I'm going to be able to sub it into the series form, which is sigma. So we know that for an arithmetic sequence, Tn is equal to A plus n minus 1 d. This is just your general form of an arithmetic sequence. I have A and I have D, so I'm going to have Tn is equal to 4, substituting in my A over here, plus n minus 1 times my difference, which is positive 7. Then if I simplify that, I'm going to have Tn is equal to 4 plus, please remember to distribute this 7 into this bracket, 7n minus 7. Great, everyone. So I'm going to be left with Tn is equal to 7n minus 3. So that is my Tn. I hope everyone's with me. Take a deep breath. You guys are doing great. What we are going to do next is we need to determine how many terms are involved in this sum. I know what the first term is, I know what the common difference is, and I have the nth term. But for a sigma sum, I still need to know how many terms are involved in the sum. How am I going to find that out? Well, I've been given the value of the last term. I'm going to use the nth term to be able to determine the term number of the last term. This is going to help me know how many terms are involved in the sum. So let's work that out together. We have the general term Tn is equal to 7n minus 3. In order to determine how many terms are involved in the summation, I need to check which term has a value of 151. Because if we go back, we can see that 151 was in fact my last term. So we're going to substitute in 151 for Tn, which will be equal to 7n minus 3. I want to isolate my n. This will tell me how many terms are involved in the sum. So if I take this negative 3 to the left-hand side, I'm going to be left with 154 is equal to 7n. Then in order to isolate n, I'm going to divide 154 by 7, which is going to leave me with 22. So I know that there are 22 individual terms involved in this sum. Now is the point where I'm going to represent it in sigma notation. So we're going to draw our sigma sign. We already know what our Tn is. So our Tn, which we can see at the top over here, is 7n minus 3. Now what I need to fill in is the number that I start substituting in and the number that will help me get the value of the last term. So we know that if I substitute in n is equal to 1, that is going to get me the a value of 4. So that's telling me, or telling the person who sees the sigma, that term 1 is equal to 4, and that is the first term involved in this sum. We now need to indicate that this sum begins at 4, but it's going to go on and on and on until a specific value. So I have to say how many terms are involved in this series. So we know that the last term of this sum is 151. So if someone is going to be doing this sigma sum, they're going to start the substitution at n is equal to 1, and they're going to go the whole way up to when n is equal to 22. Because I know that this sum is going to be involved in adding 22 terms. So it's going to go from term 1 all the way up to term 22. So guys, hopefully everyone's okay with this sigma notation. Please just make sure you check that you substitute in your Tn, your bottom number, as well as your top number, so that anyone who were to see the sigma, they could complete this sum using series. Hello everyone, welcome back to another lesson, or a continued lesson if you've been with us for a while, on sigma notation. So what I'm going to be doing in this next portion of the lesson is I'm going to be revising what sigma notation is, and then I'm going to go into an example illustrating it. Let's look at the board together. So guys, at this point, we're going to revise that I can actually use sigma for arithmetic series as well as use it for geometric series. But before I get into those examples, let's just remind ourselves of what sigma notation actually is. So sigma is an instruction to determine the sum of a sequence. The use of sigma in a series gives us the opportunity to add any consecutive terms in a sequence together and not only the first n terms. So guys, just a reminder of what's quite cool about sigma is the fact that I can actually add a certain portion of terms of the sequence together. I don't have to start at term 1 going to the last term. I could add terms together from term 3 to term 10, from term 20 to term 22. It doesn't actually matter. Sigma allows us to either do the whole sequence going from term 1 to the last term, or to do an addition of a portion of terms in the sequence. Let's go to the next slide. So just a reminder, everybody, that when we are using sigma to calculate the value of a series, please remember to always write down the first 3 terms of the sequence. So we know that sigma means that we are going to be doing a series, but we are going to write down the first 3 terms of the sequence. This is going to allow us to establish the value of A as well as D if it is an arithmetic series. And we will establish the value of R with the first 3 terms if it is a geometric series. Great. So we have another example for us here. We can see that it is sigma notation because I actually have my sigma sign. And I have been asked to sum the Tn, this is the Tn, which is 3 times 2 to the power of n minus 1, from the first term. We know it's the first term, as n is equal to 1 will indicate the first term. And we are going to add all the terms from the first term up to the 10th term. So this sum will have the first term up to the 10th term. But before I can actually think about substituting into any series formula, I need to determine the value of my first 3 terms. So what we're going to do to establish the value of the first 3 terms is we're going to substitute when n is equal to 1, when n is equal to 2, and when n is equal to 3. That's going to allow me to find term 1, term 2, as well as term 3. So when I substitute n is equal to 1, I'm going to have 3 times 2 to the power of 1 minus 1. That is just going to leave me with 3. So term 1 is equal to 3. Then what I'm going to do is have term 2, 3 times 2 to the power of 2 minus 1, which is going to leave me with 6. Then term 3 is 3 times 2 to the power of 3 minus 1, and that is going to give me an answer of 12. So because I actually have the first 3 terms of the sequence, I can start determining the values of what I will need for my series formula. So, everyone, I hope that you're okay at this point. I've established the first 3 terms in this sequence. Something that we do have to triple check before we substitute into the series formula is I need to make sure I know what type of series it is. Because, as we know, the arithmetic series formula is different to the geometric series formula. We're going to look out to see if there is a common difference or if there is a common ratio. If there is a common difference, I know that it's an arithmetic series. If there is a common ratio, I know it is a geometric series. Great, let's go back to the board. So, coming from here, I can see that from 3 to 6, I've added 3, but I've also multiplied by 2. From 6 to 12, I've added 6, but I again multiplied by 2. So I'm sure everyone will agree that having plus 3 and plus 6, that's not a common difference. But I can see that from 3 to 6, I can multiply 3 by 2 to get to 6, and I can multiply 6 by 2 to get to 12. So this example actually has a common ratio of positive 2. So that means that it is a geometric series. The last thing that I need to do before I substitute into the geometric series formula is determine how many terms are in this sum. So just a reminder, I take the top number minus the bottom number, then I add 1. So I'm going to have the top number, which is 10. I'm going to subtract the bottom number, which is 1. Then I'm going to add 1. So that means that there are 10 terms in this sequence. Great, guys. Also, just before we go on, I'm sure you'll agree with me that A is in fact 3 as it is term 1. So I have my A, I have my R, and I have my N, so I can substitute into the geometric series formula. So we know that geometric series can be written as A, 1 minus R to the power of N over 1 minus R. So the sum of the first 10 terms, I'm going to substitute in my A, which is 3. I'm going to have 1 minus 2 to the power of 10, substituting in my R and N, over 1 minus 2. Great, let's just pop this into my calculator. I've got 3 times 1 minus 2 to the power of 10, all over 1 minus 2, which is going to give me 3,069. So guys, the sum of the first 10 terms of this geometric series is 3,069. After the break, we'll go through some more examples. See you soon. Welcome back, everybody. In the next portion of today's lesson, I am going to be focusing on some additional examples of sigma sums. Let's look at the next example together. So guys, we have been given a specific series that we need to determine A, the first 3 terms of the series, B, the 100th term of the series, and by the 100th term, please note that we actually mean T100. Then we are going to determine the value of N if the sigma sum is equal to 80. So guys, just a little note, this sigma looks slightly different, but all it means is that the N is the top value and K is equal to 1 is the bottom value. I'm just showing you this as sometimes it can appear differently in different books. So let's get going with A. So we have to determine the first 3 terms of the series. We have been given our Tn. We know that being given the Tn will allow me to substitute in values. But this one might look a bit different, guys, because I actually have a K. So this, in fact, is Tk is equal to 22 minus 2k. It is the same thing as your Tn formula, except now there is a k involved. So if I look at my substitution instruction, I can see that I'm first going to substitute in for k is equal to 1. This will allow me to find the first term involved in the sum. Cool, so to find the first term, I'm going to substitute k is equal to 1. So term 1 will be equal to 22 minus 2 times 1. So term 1 has a value of 20. Then to find term 2, I'm going to substitute in k is equal to 2. So term 2 will be equal to 22 minus 2 times 2. Please note I've substituted in 2 in the position of k, which is going to give me 80. Then to find term 3, I'm going to substitute in k is equal to 3. So term 3 will be equal to 22 minus 2 times 3, which gives me an answer of 16. Great, everybody. I hope that you are with me so far. The first 3 terms of this series are 20, 18, and 16. Let's move on to B. So the next part of the question has asked me to determine the 100th term of the series. So we are finding T100. So I'm sure that everyone will agree that I have got my nth term. So please remember this is actually supposed to say Tk, not Tn, because we know that the Tn has been expressed in terms of k. So Tk is equal to 22 minus 2k. I am going to find the 100th term. So the 100th term means that I need to substitute in 100 for k. So I'm going to have 22 minus 2 times 100. Substituting in k is equal to 100 will allow me to find the value of the 100th term. So term 100 will be equal to 22 minus 200, which ultimately means that term 100 will be equal to negative 178. Great, guys. I hope everyone is with me. Let's move on to C. So we now need to determine the value of n. So this means this question is asking me how many terms are involved in the sum. So we're determining n if the sigma of 22 minus 2k is equal to 80. Okay, so the first 3 terms of the sequence which we've established are 20, then 18, then 16. It's an arithmetic series, everybody, because there is a common difference of negative 2. I'm sure that everyone will agree with me that moving from 20 to 18, I've subtracted 2, then moving from 18 to 16, I have subtracted 2. Because I'm trying to find the n that leads to the series having a total value of 80, I'm going to be substituting in 80 for my Sn. I can see that a is equal to 20 because that is my a value, and I have already established that the common difference is negative 2. Great, guys. So because I have an Sn, an a, and a d, I'm going to substitute that into my arithmetic series formula, as this is going to allow me to solve for n. Let's do that together. So we know that I'm going to be substituting in 80 for Sn, because I know that is the total of the series. N is unknown, so I'm still going to have n over 2. Then I'm going to have 2 times 20, because I'm substituting in a is equal to 20, plus n minus 1, because I'm going to be having n minus 1 because I don't know the value of n, multiplied by negative 2. Great. So we are trying to solve for n. Just to get rid of this headache fraction, I'm going to multiply both sides of the fraction or the equation by 2. So I'm going to have 160, sorry, my pen did a weird thing there, is equal to n. So all I've done is have multiplied both sides of the equation by 2. Then in my bracket, I'm going to have 40 minus 2n plus 2. In order to get to that step, I've distributed this negative 2 into that bracket. I'm going to continue simplifying, so I'm going to have 160 is equal to n times 42 minus 2n. I'm going to distribute my n in the next step. So I'm going to have 160 is equal to 42n minus 2n squared. Hopefully everyone can see at this point that it is creating a quadratic equation to solve for n. In order to solve for that, I'm going to move everything over to the left-hand side so I can handle my trinomial. So the next line will be 2n squared minus 42n plus 160 is equal to 0. In order to make my life slightly easier, I'm going to divide everything by 2. So that's going to leave me with n squared minus 21n plus 80. So the factorized form of this trinomial is going to be n minus 16, n minus 5. So n will be equal to 16, or n will be equal to 5. Now guys, I'm sure that everyone's wondering, why are there two answers for n? How come there are two different numbers of terms that I can add together to get 80? And the reason for this is that the sum of the terms increases when the terms are positive, and the terms decrease when the terms become negative. So that's the reason why I have two n values. Let's look at the next example. Great, before I go on to the next one, I hope that everyone's with me. I hope that you've got your pen in your hands and that you're doing okay. You've got this. Great, let's go to the next example. So, if the sigma sum of k plus b is equal to 10a, we need to determine b in terms of a. So, we're first going to substitute in k is equal to 1, k is equal to 2, and k is equal to 3 in order to actually determine the first three terms of the sequence. The reason why this is going to help me is because I know that this sum is equal to 10a. So I'm going to be able to use this series to create an equation to isolate b. But I know with sigma sums, I first always have to find the first three terms involved in the sum. So term 1 will be equal to 1 plus b. Why? I'm replacing k with 1. The second term will be 2 plus b, because I'm substituting k is equal to 2. The third term will be 3 plus b. The reason why having those first three terms is going to help me is I'm going to be able to establish my a and my d, because this is an arithmetic sequence. So we have my first three terms. At this point, having my first three terms is going to allow me to find my a and my d. Why is that going to help me? Well, I need to isolate b in my given equation, and I've been given Sn. So I have to find every single piece of information that is going to help me isolate that b. So let's look at the board behind us, and we're going to confirm the value of a as well as the value of d. Let's go back to the board. So we can see that term 1 has a value of 1 plus b, and this is my a. Then we can see that there is a common difference of positive 1 between these terms, because the b remains the same, except we've now moved from 1 plus b to 2 plus b to 3 plus b. So there's been a common difference of positive 1 for each of these terms. So we know that a is 1 plus b, and the common difference is positive 1. Just a reminder, for a summation involving a sigma sum, I have to determine how many terms are being added in this series. I do that by saying the top number minus the bottom number plus 1. So in this case, my top number is 5. I'm going to minus my bottom number, which is 1. Then I'm going to add 1. So there are 5 terms involved in this summation. At this point, everybody, I now can substitute into my arithmetic series formula in order to isolate b. Let's do that together. So we are going to substitute into this formula over here. We know that the summation, the Sn, is 10a. So I'm going to have 10a is equal to n over 2, and we know that 5 is my n. So I'm going to have 5 over 2. 2 times a, and I know that a is 1 plus b. Then I'm going to add that to n minus 1, which is 5 minus 1, because I know n is 5. And my common difference we discussed a bit earlier is 1. Please remember I'm determining b in terms of a. So my whole goal is to get b by itself. So let's continue manipulating this equation. So I'm going to have 10a is equal to 5 over 2 in brackets 2 plus 2b plus 4. To make my life a bit easier, I'm going to multiply both sides of this equation by 2 in order to get rid of the fraction. So I'm going to have 20a is equal to 5 times 6 plus 2b. I've just condensed and simplified that bracket. Remember, my whole goal is to get b by itself because I want to determine b in terms of a. I'm going to divide both sides of the equation by 5, so that's going to leave me with 4a is equal to 6 plus 2b. Again, guys, remember I'm expressing b in terms of a, so I want this guy by itself. So I'm going to take the 6 over to the left-hand side, so I'm going to have 4a minus 6 is equal to 2b. And then to get b by itself, I'm going to divide everything by 2. So 2a minus 3 is equal to b. Wonderful, everyone. I hope that you can see how I used the given information. So I had the Sn, and that helped me find the value of b in terms of a. So for these kinds of sums, it's important to look at what you do have and how that's going to help you isolate for the variable asked for in the question. I hope that you've enjoyed today's lesson. I've had a great time, and I hope to see you guys very soon.